Hi, this is Indraja. I'm going to explain the second question of my midterm examination. The question asked is about to explain the bubble sort and highlight the key features and how it compares and swap adjacent elements to sort the array. So when it comes here, now I'm going to explain generally what is a bubble sort algorithm. So yeah, bubble sort algorithm is nothing but it is a simple sorting algorithm that repeat the list steps to the list. That is nothing but if you have a set list, then it compares adjacent elements and swaps them if they are in the wrong order. This repeats until the list is sorted. So it is asked to do in the descending order. So we say with the compare with the large, we sort in a way such that large elements come the first and small element is the last. It is descending order. And it is also asked for key features. Key features are we can say termination. Termination is nothing but this algorithm usually stops when the pass is completed without any swaps. If we don't have swaps, then automatically the algorithm terminates firstly. And if they terminate, then it indicates that the list is sorted. And when it comes to multiple passes, yeah, here multiple passes are required because um, after each pass, the large element is shifted to the starting and slowly small element is going to the ending. And moves the correct position. And the other main feature is it is comparison and swapping also. Here the algorithm compares each adjacent elements and swaps them if they are in the wrong order as we know. So here it is asked for descending order. To sort the elements in a descending order, the algorithm swaps the elements in the first element of the pair. Yeah, if the first element of the pair is smaller than the second element, then the element swaps usually. Yeah, that is, if I want to explain, this is set 1. So I will explain it through this notepad. This is set 1. So yeah, in pass 1, mm, if I want to show you, this if 54 and 13 are compared, 54 is larger, so no need of swapping here. If 13 and 1 are compared here, 1 is smaller, so no need to swap. If I compare 1 and 9, if I compare 1 and 9, 1 is not smaller than 9, so 1 comes here. And if I compare 1 and 103, 1 is smaller than 103, so 1 will be swapping with the 103. And if I compare 1 and 29, as usual, 1 is smaller than 29, 29 is swapped with the 1. And if I compare 1 and 16, 1 is smaller than 16, so 1 is swapped with the 16. And if I compare 1 and 98, you know this 1 is smaller than 98, so it comes here. Yeah, this is that. So this is my pass 1, if we consider. And if I come to pass 2, I mean, this is also same. So yeah, now I am going to compare 54 and 13. Usually 54 and 13 are, yeah, if I compare 54 and 13, 54 is larger, so no need to swap. If I compare 39, 9, 9 is larger than 13, I mean smaller than 13, so no need to swap. If I compare 9 and 103, 9 is smaller than 103. So as per descending order, we need to swap 9 and 103. And if I compare 9 and 29, as 29 is larger, again 9 will be swapping with 29. And if I compare 9 and 16, usually 9 is smaller than 16, so 9 will be swapped with 16. And if I compare 9 and 98, again 9 is smaller than 98, so 9 is swapped with 98. So this is my second pass. And if I come to pass 3, Here, if I compare 54 and 13, this is good because 13 is smaller than 54. And if I compare 39, 103, 13 is smaller than 103. So it should be swapped. And if I see 39, 29, 13 is smaller than 29. So again, I should swap 13 with 29. And if I see 39, 16, again 13 is smaller than 16. So it should be swapped. And again, if I say 3998, of course, like 13 is smaller than 1998. So it should be solved with 98. So this is my other pass. And again, when I come for pass 4, here, if I say 54 and 103, 54 and 103, yeah, usually 103 is larger and 54 is smaller. So 54 is swapped with 103. And if I check 54 with 29, it is smaller, it's fine. So yeah, if I check everything, 54 is larger than everything. So the place is here. This is correct because 54 is larger than 29. It comes then here, but it doesn't swap. So 54 stays there as usual. So now I should go to pass 5. Here, 103 is larger than 54, so no problem. And 54 is larger than 29, so no issue. And 29 is larger than 16, so no need to swap. But here, 16 is smaller than 98. So here we swap 98 and 16. And if we see 16 and 13, it is good, so no need to swap. So this all remains the same. Again, if I come to pass 6, here 103 and 54 is good, and 54 and 29, 29 is small, it is also good. And if I say 29 and 98, 29 is smaller than 98, so I should swap this. Sorry. Yeah, so I should swap this 29 with 98. And if I say 29 and 16, it is good. And if I say 16 and 13, yeah, everything good looks actually. So now I want to go to pass 7. So here 103 and 54, 54 is smaller, it's fine. And if I say 54 and 98, 98 is larger. And if I say 54 and 29, it is larger. So everything looks good. So in pass 7, I got my descending order from large number to small number. So yeah, this is what I have done using bubble sort algorithm. I have swapped it from descending order, in descending order. So this is my sorted list. And if I comes to second question, it is asked like, this is set 2. We need to say Wahoo tall complexity is big of n. Because if we want to swap this element, this is already in a descending order. If we swap 98 with 45, no swap is required. If we see 45 with 23, no swap is required. For all this, no swaps is required because it is already in a descending order. So, like for already like sorted array, and it is already in descending order, the algorithm can achieve big of n time complexity. By adding a flag to check if any swaps were there made during the pass. But like there is no swaps were made. So because the array is already sorted, here the algorithm can terminate easily by avoiding unnecessary passes because we don't need passes. It is already in descending order. So here the best case is like big of n. And if I want to explain exactly the set 2 question, since the array is already sorted in a descending order, the algorithm completes in a single pass, resulting in a time complexity big of n. Yeah, that's it. Thank you.